This is a review for the 2.4 to 3.2 test in precal. So first one, it says to solve. So I'm going to zoom in a little bit. Just move across as we go down and over. Give ourselves a little bit more room. And so what I need to do is I need to set it equal to 0 to start with. Hopefully you did that. And we'll just set it equal to 0. I need to distribute all this, so this is going to be an x squared minus an 8x plus 16 minus 4 equals 0. So that's an x squared minus 8x plus 12 equals 0. So I know up here it's an inequality and I changed it to an equal. That's okay. And then this factors is an x minus 6, an x minus 2. So remember, we do this little graph thing. This is an x equals 6 and 2. So I'm going to put 2 here, put 6 here. I'm going to test numbers down less than 2, and it comes out positive. Test numbers between 2 and 6, comes out negative. And then I test numbers above 6, and they come out positive. I wanted things greater than, I guess, 0. When you move it over, minus 4 is greater than 0. So that means I want the green region and the red region. So writing that in interval notation, negative infinity to 2, or 6 to positive infinity. And that's it. Number 2. Well, this one, instead of trying to factor all that, you know what I did? I graphed it, and I saw where it crossed the x-axis. Because I could factor, I could do that. And it crossed at -1, -2/3, and then also at 3. And then I want the areas that are less than 0, so I figure out what the sign is. This section will be negative. Anything less than -1 came out negative. Between -1 and -2/3, it came out positive. Between -2/3 and 3, it was negative. And then 3 above 3, it was positive. So I want the negative regions. So that was from negative infinity to a -1, and this is a bracket because of this equal sign. The one before it, there was no equal sign, that's why there were parentheses on it. Or -2/3 to 3. Number 3. Well, that doesn't factor, so I graph it, and I look at it, and it never crosses the x-axis. It's up here somewhere. Maybe it's over on the other side. I forgot what it looked like. So that means there is no solution, because I wanted it when it was less than 0. If I wanted it when it was greater than 0, it would have been all real numbers. This one's less than 0. It was always above the x-axis. It was never down here, so no solution. 4. This one's a rational function. I need to move the 1 over. So this is an x plus 6 over a 4x minus 3 minus 1 is greater than 0. I need to get a common denominator. I like that 1 because it makes it easy to do. So this is going to be a 4x minus 3 over a 4x minus 3. So then I can combine my fractions. I get an x plus 6 minus a 4x plus a 3, because I needed to take this negative and distribute it to both, so that made that a plus instead of a minus, all over 4x minus 3. So the numerator simplifies down to -3x plus 9 all over 4x minus 3. So I get that x is equal to, or x cannot be, in the denominator, it cannot be 3/4. And then I also need to take my numerator and figure out what my x-intercepts are. So this is going to be a negative 3x plus 9 equals 0. So this is going to be an x equals, move the 9 over, divide by negative 3. It's going to be a positive 3. So those are the two numbers that I want on my number line. 3 and a 3/4. And then check the signs. So when I'm down here, below 3/4, it's going to be a negative. And then between 3/4 and 3, it's a positive. And then above 3, it's a negative. So going back to look, I want where it's greater than 1, or greater than 0, excuse me. So I want the positive region. So my solution to this one is going to be from 3/4 to 3. And no bracket because there is no equal sign down here. 5, we're going to solve this. This is bringing in some old stuff this time. This is a review problem mixed in the middle of it. I need to solve for my radical by itself, so I need to move the 4 over. So this is 2x minus 4 equals the square root of 7x minus 12. To get rid of the radical, I need to square both sides, not every term, but both sides. So the left-hand side becomes a 4x squared. I can multiply and double that, so minus 16x plus 16 equals a 7x minus 12. Need to subtract the 7x and then add the 12. I get a 4x squared minus 23x plus 28 equals 0. If you can factor that, go for it. If you can't, use the quadratic formula, okay? So I'm going to show you x is equal to negative b, so 23 plus or minus the square root of b squared, 23 squared. If you notice I dropped the negative, that's fine because once you square it, it always is positive. Minus 4 times a times c all over 2a. So we get x is equal to 23 plus or minus the square root of 81 over 8. So that's 23 plus or minus 9 over 8. So that becomes, just simplifying that, once with a plus, once with a minus. So remember it's 23 plus 9 over 8, 23 minus 9 over 8. And then it comes out to be 4 or 7/4. Now, you have to check your answers because on a radical it may not have worked. When I go and plug it back in, this one doesn't work. So my only solution is x equals 4. Alright, I want you to analyze the graph of each function. So just kind of sketch it for me what you think it might look like. This one's an exponential growth because the base number here is larger than 1. So it goes up, across here at 1, and then we're going to go from there. Describe its domain. The domain is the x, so it's going from negative infinity to positive infinity. The range is the y. There's an asymptote there, so it never touches the 0, so it's 0 up to positive infinity. Your intercepts, there's no x-intercept because of the asymptote, but there is a y-intercept. And your y-intercept is at 1. The asymptotes, well, that's going to be at y equals 0 because it's the x-axis. Our in behavior, the limit as x goes to positive infinity, because it goes to positive infinity, f of x is going to positive infinity. The limit as x goes to negative infinity, f of x goes to negative infinity. And is this function increasing or decreasing, and where? Well, remember, this one's always increasing. It's increasing from negative infinity to positive infinity. That's it. Make sure you go systematically through those so you don't skip anything. So we're going to tell about the transformations. This one has 2. It goes up 2. And then this negative in the front. Remember, the 6 is the base number, so it's not a part of it. but it's outside that negative. So it's a vertical, and the negatives reflect, and it reflects over the x-axis. You could say a vertical reflection over the x-axis. This next one has two things. It's got a 3 here, and then it's got this negative up there. Hopefully you can see it better on your paper. So the 3, it's outside, so it's vertical. It's larger than 1, so it's a stretch by 3. The negative on the x is on the inside, so that negative is on the inside. And negatives are reflections. And inside is going to reflect it over the y-axis. This one's different. Here's a transformation. It's the base e. That's a 0.5. So it's on the up there with the x. So it's inside, so it's a horizontal. 0.5 is less than 1. So inside that means it's a stretch, and it's by 2. Because the reciprocal 0.5 is 1 over 0.5, which is 2. All right, so let's do some word problems. These are your growth and decay. So our equations is principal times 1 plus r over n to the nt. And if it's continuous, you're going to use p e to the rt. Your final amount's equal to this or this. So it depends on how the compounding is done. So if you have $2,000 and you invested in an online savings account earning 6% per year, how much will be in the account at the end of 5 years if there's no other deposits or withdrawals and the interest is compounded? First of all, semi-annually. So knowing that, what is n going to be? N is going to be 2. So the principal is the initial amount, 2,000. 1 plus your rate as a decimal, so 0.06, all over 2 to the 2 t. T is 5 years, this one. So I put that on my calculator. I get 2,687.83. Now, if it's continuous, it means we have to change equations, and we're using the PE to the RT. Principal still 2,000. E, your rate 0.06, and your time is 5 years. Put that in your calculator, 2,699.72. So we're going to do one with population now. And it's declining. That means it's going to go down. Okay. So at a rate of 8%, if the current population is 15,926, predict the population of 5 and 10 years. So I want it 5 years and 10 years. I'm just going to write it below it. Maybe I should write it like that. And then 5 years here and 10 years over here. So this is the equation we're going to use. Annually means n is 1. 0.08 divided by 1 to the 1, and then t. I'm going to change for the different ones. Once for 5, once for 10. So I put that on my calculator, and for 5 years I get 10,497. And then for 10 years I get 6,918. Now, did that drop? Yes, it did. So at least I know that part's right. Now, continuous, 15,926 e to the r. It's declining, so it's a negative. And then t. I'm going to put in a 5 and a 10. I get 10,676 for 5 years and 7,156 for 10 years. Number 12, find the asymptotes in the equations of the vertical, horizontal, or oblique asymptotes. Or it says find the domain. I had the wrong word. Find the domain. Well, that comes from knowing what our asymptotes are. So the first thing I know is that this is going to be an x equals 4. That is my vertical asymptote. And then I need to look at the leading coefficients, or not leading coefficients, leading terms. And I noticed that the numerator is one more than the denominator, and that means it's going to be an oblique or a slant asymptote, which means I am going to do some synthetic division because this is just a binomial with a degree of 1. So 1, 9, and 20. 1 here, 4 here. It's going to be a 13. I really don't care about any of the rest of that. So my oblique asymptote is going to be y equals 1x plus 13. I don't care about the remainder, so we can stop there. And then what my domain is, it comes from right here, my vertical asymptote. So I can't use the 4, so I'm going to jump over it. And that is my domain. I could have also written it set of x such that x does not equal 4 and x is an element of all real numbers. All right, 13. Determine any asymptotes and intercepts. State the domain. So our asymptotes come from the denominator, and that's going to be vertical asymptotes. X equals 0, x equals 5, and x equals -2. Those are my vertical asymptotes. Also, I'm going to look here and see the degree in the numerator. That's going to be an x squared. In the denominator, that's going to be an x cubed. The denominator is greater than the numerator, so I have a horizontal asymptote at y equals 0. If the denominator is larger, it's always at y equals 0. And then I think on the answer key, I forgot to tell about the intercepts. Well, that comes from the numerator. I've got an x equals a -6 and a -4. Those are my two x-intercepts. 14. Oh wait, now I forgot to say the domain. Gotta watch me here. So skipping all of the vertical asymptotes, I'm going to go from -infinity to -2 or -2. The next number up would be a 0, or 0 to 5, or 5 to positive infinity. Remember, however many vertical asymptotes you have, 1, 2, 3, you're going to have one more group, 1, 2, 3, 4. 14. Determine any asymptotes, holes, and intercepts and state the domain. So kind of the same. So our asymptotes, our vertical asymptotes, well, you've got to be careful because it could be a hole. How do you tell if it's a hole? If the groups cancel out, if it's the exact same. So there's a hole at x equals 1. You have a vertical asymptote at x equals -3. And the intercept is going to be x equals -4. Now be careful. This is a vertical asymptote. This is an intercept. So don't confuse them. They're both in x equals, okay? And then the domain, we jump over the vertical asymptote and the holes, so that's 2, so we should have 3 groups. So -infinity to -3, or -3 to 1, or 1 to positive infinity. 15, we get to solve this. So I am going to move over to the side here to solve it. So looking at this, I need to try to get the denominators all the same. A few things that I noticed right here, pointing this out, is that this, I want to have my y's first. And the reason I want that is because I can factor this term to be a y minus 2 and a y plus 2. And see, it's a y minus 2, so I'm going to just factor out a negative, so that's going to change the sign to a plus, and that changes that. So now this is a y minus 2. Okay, so this has both terms in the denominator, or both, not terms, it's both factors, sorry. And this has the y plus 2, so I need the y minus 2 for this group. And then on the next one, I have the y minus 2. I need the y plus 2. Now, I'm not going to multiply the denominator back out. So the top, the first one here, if I distribute the 2, this is going to be a 2y minus 4 plus, I'm going to distribute the y here, y squared plus 2y equals y squared plus 4. And all of that is over the y minus 2, y plus 2. And since it's all over the same thing, I can actually just drop the denominator at this point. And so now I'm going to combine like terms. This is a y squared plus a 4y minus 4 equals y squared plus 4. Now, it's the exact same on both sides, so I can cross it out. If the signs are opposite, don't do that, okay? They have to be exactly the same, and then you can cancel them out on both sides. So I'm going to add 4 to both sides. This is equal to 8, so y is equal to 2. But here's the kicker. Did all that work, and what can y not equal? Y can't equal a negative 2. It can't equal a positive 2 either. So this won't work. So there is no solution. All that for nothing. That's okay. It was fun. All right, 16. Write a rational function with x-intercepts at x equals 0. So that means I need an x in the numerator. X equals 4. So that's going to be an x minus 4 in the numerator because it's x-intercepts. We have a vertical asymptote at x equals 1. So that's going to be an x minus 1. And x equals 6. So x minus 6. And we have a horizontal asymptote at y equals 0. What that means is that the denominator has to be larger, has to have a degree larger than the numerator. Well, right now, I've got 1, 2x, so this is an x squared, and this is an x squared. I need to get more in the bottom, but I cannot add any different asymptotes or intercepts, so I'm just going to go and square one of them. Now I have an x to the third in the denominator and an x squared in the numerator, and that works. So we'll just say this is equal to f of x. And that's it. All right, 17, we're going to list all the possible rational zeros. So it's your constant term, which is 20, and your leading coefficient term, negative 4. I don't care about the negative because everything's a plus or minus anyway. So what are all of the factors of 20? A 1, a 2, a 4, 5, 10, and 20. All the factors of 4. 1, 2, and 4. And I have no idea why I just wrote that parentheses in the front. And then it's all of these factors of 20 over all of the factors of 4 with a plus or minus. So I don't care if you write plus or minus and then a parentheses and write them all. But if you don't, you have to write a plus or minus in front of each of them, which I'm going to do right now. Okay, so that's all over 1. Now all over 2, 1/2. And then I have 2 over 2, which is 1, 4 over 2, which is 2, 5 over 2, plus or minus 5/2. 10 over 2 is 5, 20 over 2 is 10. I need a 1/4, because 1 over 4. And 2 over 4 is a half, 4 over 4 is 1, 5/4. That one's not in the list yet. Then 10/4, that would be 5/2, and 20/4 would be 5. So that's all of them. Now which ones work? Please do this the easy way. Don't sit and try them all. Graph. See which ones work. And they cross at 2, 5, and 1/4. negative 1/4. That's it. $18. We're going to solve. So I need to move this over to the same side. Remember, everything has to be equal to 0 when you're solving. So 6x to the 4th plus 41x cubed plus 42x squared minus 96x plus 32 equals 0. Now, I graph and I look and see, where does it look like it's going to cross the x-axis? Look and see, zoom in, look around. Some of you just learned how to zoom in on your calculator. That's great. So it looks like it crosses at x equals negative 4, 1/2, and 2/3. So I'm going to double check, because sometimes things are a little deceiving on calculators. I check this. I get a negative 24. I get a 17. And a negative 68 when I multiply by the negative 4. And then I add them up to get a negative 26. Multiply by a negative 4. I get 104. And then I subtract 96 from that. I get an 8. And then I multiply it by a negative 4. I get a negative 32. And it gave me a 0. Yes, it worked. Now, I'm going to try the next number. I'm going to try a half, because I actually kind of like that half. So this is 6 times a half is 3. Add it to 17, that's a 20. Multiply by half, that's a 10. And subtract 26 from that, that's a negative 16. And half of that, that's a negative 8. And it's a 0 again. Yay! Now I want to go to that 2/3. That's my least favorite one. Then when I do that, drop the 6, multiply by 2/3, I get a 4. Add 20, that's 24. Multiply by 2/3, that's 16, and I get 0 again. Woohoo! So then I have a 6x plus 24 equals 0. Let's see what that comes out to be. I know what it is from the graph, because it was tangent to the x-axis at negative 4, but we're going to just double check it to be sure, which meant that I could have done negative 4 twice in the box, but I didn't. I wanted to do it this way, and it did. It came out to be a negative 4. So my answers are this, and the negative 4 has a multiplicity of 2, because it showed up twice. 19. We need to do our upper and lower bound test. So show them to me. How are you going to tell what the numbers are? I am going to graph them, and I'm going to put a number above where it crosses the last time. So I picked a 7, and then I'm going to show using my upper bound test. Do you guys remember what it has to come out to be if it's an upper bound? Hopefully. All of the numbers down here need to be positive. If they're all positive, it's the upper bound. So this is 2, a 14, a 1, 7, a 28, 196, 205. I know this is going to be positive, but I need to finish it out because I have to show that that works. They're all positive, so that means 7 is an upper bound. Now the lower bound, remember what needs to happen on the lower bound? It needs to alternate signs. So I graphed it. I thought negative 2 was a good one to try. So using the same thing. So 2, negative 4, negative 17, 55. That's not 55. The one below it is. This is a 34. Yeah, that's better. 55. A negative 110. So a negative 101. This is a 202. And then 182. Positive, negative, positive, negative, positive. It alternated. So that's the lower bound. So all of my answers have to fall between negative 2 and 7. That's it. 20. This is describe. Please do not find, do not list. Just describe. So, First of all, I'm going to find all the positives. I go negative, negative. Oh, sign change, positive, positive, negative. There are two sign changes, so there are 2 or 0 possible real positive zeros. Then we have negatives, so I'm going to find f of negative x. That's a negative 3x to the 4th. You guys remember which one changes signs? Only the odd powers. So this is plus 5x to the 3rd plus 4x squared minus 2x minus 6. Go negative to a positive, 1 sign change. And then this is another positive, positive to negative, that's a sign change, and negative to negative. There are 2 sign changes, so that's 2 or 0. Now let's talk about those imaginaries. Your imaginaries, remember? You take the 2 lowest and add them together and subtract it from your highest exponent, which is your degree. So 4 again, and subtract off. You add your 2 highest here. 2 plus 2 is not 2. 2 plus 2 is 4. So it's from 4 to 0. 4, 0. Don't miss the 2 in the middle. That's it. There could be 4, 2, or 0 imaginary solutions. 21. We're going to use the fact that 3i is a 0. So that means that x minus 3i has to be a 0. And x plus 3i has to be a 0. And it says to find all the complex zeros, write the linear factorization of the function. So I have 2 of them. I know there are going to be 5 factors. What's the easy way to find the rest of the factors if they're real? Hopefully you just thought, graph! Yes, you are right! Graph them and see where it crosses the x-axis, please. They cross the x-axis at 4. Sorry, a negative 4, a 3, and a 1/2. So, a negative 4 as a group, factor group, it's an x plus 4. Then the 3 is an x minus 3. And this 1/2, that's the one we have to think about. I don't want an x minus 1/2. So you're going to swing that denominator up in front of the x. So 2x minus 1. And we're done. Yay! 22. This is another review question kind of stuck in the middle here. We want to find the average rate of change over that interval. So I'm going to find f of negative 5. So that means I need to plug in a negative 5 for each of the x's. So this is negative 5 to the 4th. Minus 6 times negative 5 squared plus 4 times negative 5. And that comes out to be 455. The next one, I need to find f of negative 3. When I do that, that's negative 3 to the 4th minus 6 times negative 3 squared plus 4 times negative 3. And that comes out to be 15. Now, the average rate of change, guys, that's just the slope. So this is your y's. So it's the change in the y, 455 minus 15, over the change in the x. And that would have been, the interval that we just looked at right here. The negative 5 goes with the 455, so negative 5 minus the negative 3 goes with this one. So this comes out to be 440 over negative 2, which is negative 220. Alrighty, my friends, this is the last page. Woohoo! So I'm going to break 512. I need to break it down into 8s because that was an 8. So 8 and 64. And 64 is 8 and 8. So this is log base 8 of 8 to the 3rd. And then all of this goes away because it's the same base, and I'm left with a 3. This is a fun one. The bases were already the same. I didn't have to do anything, and I'm left with a 1. 27, the natural log of 32. Put it in your calculator. 3.4657. Log base 2 of 1 over 32. Well, I'm going to have to break the 30 down and 2 down into 2s. So 2 and a 16, 2 and an 8, 2 and a 4, and the 4 is 2 and a 2. So this is log base 2 of 1 over 2 to the 1, 2, 3, 4, 5, 2 to the 5th. But that's down in the denominator, so I need to bring it up to the numerator. So that's 2 to the negative 5, so my answer is negative 5. This one, it's a log base 10. There are 1, 2, 3, 4 zeros, so it's 4. 28, the natural log. Well, this is the denominator, so it can't cancel out quite yet, but if I move it up and change that, now they're inverses. I'm left with a negative 3. I know you guys like those. 29. Analyze the graph of each function. Describe the domain, the range, the intercepts, asymptotes, and behaviors, and whether the function is increasing or decreasing. So I'm going to graph it. And when I graph it, don't cross any asymptotes. Got it? All right, so the domain. There's an asymptote right here. So it's from 0 up to positive infinity. Your range, well, it went down forever and it's going to go up forever. So negative infinity to positive infinity. Remember, that better be a positive infinity on the right side. And if you write an infinity on the left side, it better be a negative infinity. Your intercepts, you have an x-intercept at x equals 1. If you look back at the one on the first page, these are inverses of each other, so things kind of flip around. You have an asymptote at x equals 0. So you have, this is a vertical asymptote. Okay. You're in behavior, the limit as x goes to positive infinity, f of x goes to negative infinity. And if you notice right here, yep, so the other one is the limit as x goes to 0. Check that out. From the positive side, f of x goes to negative infinity. And the last, this function is always increasing. So it's increasing from 0 to positive infinity. And it's 0 because, remember, it doesn't cross the 0 on the x. Okay. Last one, transformations. What's going on here? This is a half. And so it is going to be outside, so it's a vertical. It is what it is, so it's a vertical compress by a half. The next one, this minus 2, it is not in parentheses with that x. So it is not with that x, so it's moving it down 2. Now, if it was this, that's totally different, but it wasn't. It was. Those are two different things. All right, that's it. See you guys tomorrow or later, whenever you watch this.